Dear students, welcome to Army Public School PMA Resource Network. Before we start our today's subject, Maths, please subscribe this page and click on bell icon to receive the upcoming notifications on our channel. I am your teacher, Nida Makbul. In our today's subject, Maths, we are going to discuss factorization of quadratic expressions and sets. Week 7. Topic: Factorization of quadratic expressions, given on page 54 to 60. Learning objective. In this module, we will learn before getting into discussion of factorization. Now let's recall what is factorization. Factorization. The first method that I'm going to use is factorization using algebraic disks. Algebraic disks are a useful tool for expansion as well as for factorization. Let us understand this method through an example. Let's say the quadratic expression that has to be factorized is x squared plus 5x plus 6. Now recall that in this method we form a rectangular array. The rectangular array has four distinct regions. The top left region contains the x squared disks, the bottom right region contains the 1 disks, and the other two regions contains the x disks. Now let's place them in their appropriate region. X square at the top left and 6 1 disks at the bottom right region. Now we put in 5 x disks to form the rectangle. Now let's use the multiplication table where we multiply the top by the side. Now what two numbers when multiplied would give us a product x square? They are x and x. So I'm going to write 1x at the top and 1x at the side. Now what two numbers when multiplied would give us a product x? That would be x and 1. As x is already written on the side, so I would write 1 at the top. I would do the same for the next two disks. Moving on to the next row, here the first disk is x and on the top x is already mentioned. Now I know 1 multiplied with x is x, so I will write 1 on the side. Similarly, 1 multiplied with 1 is 1. This means I have chosen a correct disk. Same goes for the next row. X is written on the top, so I will write 1 on the side. So quadratic expression has been decomposed into linear expressions. Hence, two linear factors of x square plus 5x plus 6 are x plus 2 and x plus 3. Notice that in this case, the constant term 6 is factorized into 2 multiplied with 3 and the 5 discs are divided into two groups, 2x and 3x, to complete the rectangle. Let's discuss this method for another quadratic expression, x squared minus 5x plus 6. First, we will draw rectangular array. Now placing discs in their appropriate regions. X square will be placed at the top left and 1 disc will be placed at the bottom right region. Now we put in 5 minus x discs to form the rectangle. Now let's use the multiplication table where we multiply the top by the side. Now what two numbers when multiplied would give us a product x square? They are x and x. So I'm going to write one x at the top and the other x at the side. Now what two numbers when multiplied would give us a product minus x? That would be x and minus 1. As x is already written on the side, so I would write minus 1 at the top. I would do the same for the next two discs. Moving on to the next row, here the first disc is minus x and on the top x is already mentioned. So now I know minus x multiplied with x is minus x, so I will write minus 1 on the side. Similarly, minus 1 when multiplied with minus 1 is plus 1, so this means I have chosen a correct disc. Same goes for the next row. X is written on the top, so I will write minus 1 on the side. So quadratic expression has been decomposed into its linear expressions. Hence, two linear factors of x squared minus 5x plus 6 are x minus 2 and x minus 3. Notice that in this case, the constant term 6 is factorized into 2 and 3, and the 5 discs are divided into two groups, minus 2x and minus 3x, to complete the rectangle. The second method which I want to discuss is factorization using multiplication frame. For that, we will consider another example, x squared plus 7x plus 10. So let's draw multiplication frame. There are few steps which you have to follow to factorize this expression. Step 1. Write x squared in top left corner and 10 in the bottom right corner of the multiplication frame. Step 2. Consider the factors of x squared and 10. Possible factors of x squared are x multiplied with x. Now let's discuss factors of 10. 10 can be factorized as 1 into 10 or minus 1 into minus 10. Another pair could be 2 multiplied with 5 or minus 2 multiplied with minus 5. Just remember that you will select those factors which when added will give you the middle term, which in this case is plus 7x, and which when multiplied would give us a product plus 10. Now as 10 is positive, so we will choose factors 2 and 5 as their sum is 7, and when we multiply them we will get a product of plus 10. Now placing the factors in the first column and in the first row. Step 3. Multiply them to complete the multiplication frame. X multiplied with 5 is 5x and 2 multiplied with x is 2x. Now check whether the result matches the given expression. Therefore, the linear factor of given quadratic expression x squared plus 7x plus 10 are x plus 2 and x plus 5. To understand this concept better, let's consider another expression x squared minus x minus 12. Again following same steps, First, we will draw multiplication frame, then placing x square in the top left corner and minus 12 in the bottom right corner of the multiplication frame. Now, considering the factors of x square, that are x and x, considering the factors of minus 12, there are different possibilities, which are 1 into minus 12 or minus 1 into 12. It could be 2 into minus 6 or minus 2 into 6. Another pair is minus 3 into 4 or 3 into minus 4. Now remember that you will select those factors which when added would give us the middle term, which in this case is minus 1, and it would give us a product of minus 12. So we will select 3 and minus 4. Why? Because their sum is equal to minus 1 and their product is equal to minus 12. Now placing them in the column and in the row. Now we will multiply to complete the multiplication frame, and we will check whether the result matches the given expression. Therefore, the linear factor of the given quadratic expression x square minus x minus 12 are x plus 3 and x minus 4. The next method is factorization using midterm break method. I will use 3 different types of quadratic expressions to explain this method. Let us consider a case b square plus 8b plus 15 in which the coefficient of the squared variable is 1. So what we will do is we will only factorize the constant term, which in this case is 15. Now possible factors of 15 are 1 into 15 and 3 into 5. Now we will consider those factors which when multiplied would give us a product of plus 15 and which when added would give us a sum of plus 8. As all terms are positive, so I have only considered positive factors. So I will select 3 and 5. Why? Because 3 multiplied with 5 is equal to plus 15 and 3 plus 5 gives us a sum of plus 8. Now after splitting, 8b can be written as b square plus 5b plus 3b plus 15. In the next step, we will find out the common factor, which for the first pair is b and for the second one is 3. Again finding out the common factor from both the terms, we get b plus 5 multiplied with b plus 3, which is the resultant and is also in the product form. Now in this example, we will consider a case 4r square minus 7r plus 3 in which the coefficient of squared variable is not 1. So what we will do is we will first multiply the coefficient of r square and in term 3, and then we will factorize the product, which in this case is 12. Now possible factors of 12 are 1 into 12 or minus 1 into minus 12. Another possibility is 2 into 6 or minus 2 into minus 6. Another case could be 3 into 4 or minus 3 into minus 4. Remember that we have to calculate all those factors which would give us a positive product. Now I will select minus 3 and minus 4. Reason? Because which when multiplied would give us a product of 12 and when added would give us a sum of minus 7. After splitting, minus 7r can be written as minus 4r and minus 3r. Now in the next step, we will find the common factor, which for the first pair is 4r and for the second one is minus 3. Again finding the common factor from both the terms, which is r minus 1, we get resultant r minus 1 multiplied with 4r minus 3, which is in the product form as required. In the last example, we will consider a case 24h square minus 15h minus 9 in which the coefficient of the squared variable is not 1. Now we observe that 24, 15 and 9 all are divisible by 3. This means they have a common factor of 3. So first we will find out the common factor and express it as 3 multiplied with 8h square minus 5h minus 3. Now, in the next step, what we will do is we will multiply the coefficient of h square and the constant minus 3. The product is equal to minus 24. Now we will find out the factors of minus 24. Possible factors are minus 1 into plus 24 or 1 into minus 24. It could be minus 2 into 12 or 2 into minus 12. Another pair could be minus 3 into 8 or 3 into minus 8. Last possibility is minus 4 into 6 or 6 into minus 4. Now we will select those factors which when multiplied would give us a product of minus 24 and a sum of minus 5. So I will select 3 and minus 8 as my difference is negative, so the larger number should be negative. Now 5h can be expressed as minus 8h plus 3h. In the next step, we will find out the common factor, which for the first pair is 8h and for the second one is 3. Again, finding the common factor from both the terms, which is h minus 1, we get the resultant 3 multiplied with h minus 1, 8h plus 3, which is in the product form as required. Now there are few steps which I would like you to remember before solving these questions. Remember, you have to multiply the coefficient of x square and the constant. Then you will factorize this product. Look for two numbers that add up to the number coefficient of x and multiply to give product of x square and the constant. Make pairs of two terms and find common factor amongst them. Express the answer in the form of factors. It is a good practice to recheck your answer by multiplying the two factors to get the original quadratic expression. Also remember that any quadratic expression has only two linear expressions as its factors. This is your homework for week 7 related to exercise 2b. Solve these questions with proper steps and submit them on AIS. You have to do practice nows from page 56 to 60 and selective parts of question 1 to 4 of exercise 2b given on page number 60. Week 8. Topic: Introduction to Sets, given on page 64 to 69. Learning objectives. In this module, we will learn to recognize and describe a set, list and describe the elements of a set, recognize the number of elements in a set, recognize an empty set, state and use the term universal set. Now let's define what is a set. A set is any collection of well-defined and distinct objects. For example, set of numbers like set of prime numbers, set of natural numbers, set of whole numbers, or set of English letters, commonly known as the alphabets, or set of jewelry items, set of crockery items, set of musical instruments, etc. In everyday life, we often encounter a collection of objects such as a pile of books, a bunch of keys, a team of players, and a school of dolphins. In English, we use different terms such as pile, bunch, and team to describe different collection of objects. In mathematics, we use the term set to describe any collection of well-defined and distinct objects. Elements of a set. The objects used to form a set are called its elements or its members. Generally, the elements of a set are written inside a pair of curly braces and are represented by commas. The name of the set is always written in a capital letter and the elements are denoted with small letters. Let's say S be the set of all the vowels. Now we can list its members in set notation as A, E, I, O, U. Since the letter A is an element of the set S, we write A belongs to S. Since the letter B is not an element of the set S, we write B does not belongs to S. Since there are 5 elements in S, we write number of elements in set S is equal to 5. Remember, epsilon denotes is a member of the set, and epsilon with a slash denotes that this object is not a member of the given set. N brackets name of the set denotes the number of elements in any given set. There are various types of set, but we will discuss only two. The first type is finite set. A set which has countable number of elements is called a finite set. For example, set of positive multiples of 3 less than 100. Second type is infinite set. A set which has uncountable number of elements is called infinite set. For example, a set of natural numbers or whole numbers or prime numbers, etc. A set is not any collection of objects. The objects in a set must be well defined and distinct. For example, if we consider a set T which has two elements P and P, then this set is not a well-defined set because the elements in the set are not distinct. However, if we consider another set T which has two elements P1 and P2, then this set is well defined because it has distinct objects as its elements. There are a few ways to describe a set. A set can be expressed in words, its elements could be listed, or we can describe a set in set notation. Let's consider a set S which contains 4 elements 2, 4, 6 and 8. If I want to describe this set in words, I will say set of all positive even integers less than 10. If I want to list its elements, I will write the elements inside a pair of curly braces and the elements would be separated through commas. If I want to describe the set in set notation, I will say S is a set which contains element X and X is such that X is a positive even integer less than 10. Now what are equal sets? Two sets are equal if they contain exactly the same elements and we would write A equals B. For example, if set A contains 1, 2, 3 and 4 and B contains 2, 4, 1 and 3, then all the elements of set A and B are same such that A is equal to B, although the order of the elements are different in A and in B. Also note that if A is equal to B, the number of elements of A is equal to number of elements of set B. Empty set. A set that does not contain any elements is called an empty set or a null set. We use the symbol phi to describe an empty set. For example, C is an empty set. The number of elements in set C is equal to 0. Also note that a set which contains itself an empty set is not an empty set. It is a set containing one element and that is itself an empty set. There are a few points I would like you to keep in your mind before starting your written work. Number 1. Define a set as a collection of objects which are clearly defined. Number 2. Recognize the objects belonging to a set are called its elements. Number 3. Recognize the symbol epsilon which means is a member of. Use the symbol n bracket name of the set to denote the number of elements of a set. Number 5. Recognize the empty or null set to be a set containing no elements. Number 6. Recognize the two sets are equal if they have same elements although their order can be different. This is your homework of week number 8 related to exercise 3A. Solve these questions with proper steps and submit them on AIS. You have to do practice now from page number 64 to 67 and selective parts of question number 1 to 13 of exercise 3A given